and share my screen. So what I'd like you all to do is go on to Canvas and download this Eagle mold.sldprt. That's the SolidWorks part. And we're going to start off by essentially making a mold manually inside of SolidWorks. And then after we do that, we're going to take a look at some processes for kind of automatically making a mold using some of the tools in SolidWorks. The reason we're doing it in this order of operations is that I kind of like doing the manual method better. I think that it generally works a little bit more reliably than using some of the built-in mold tools, and it gives us more control over the process. So I'm going to show you guys my preferred method, and then kind of show you some of the tools that exist inside SolidWorks as more of a, hey, you can also do it this way if you don't want to do it the way that I did it. Sound good? I hope so, because it's what we're doing. All right, so I've got that part downloaded. I'm going to open it up. Oh, that's the wrong one. I don't want the mold part. I want the actual Eagle part. So go to the Monday one, not the Wednesday one. Download the Eagle, not the mold Eagle. We're going to make this part using the first part. So open up the Eagle SLDPRT. Yeah. I've got a little bit of error in here that I think I corrected last time, but I must not have reopened the part. It's okay, we can still use this piece. I guess before I go into the design or the construction of this, let me just note a few things. That when I made this part, I designed it such that the components themselves would have a draft with a natural parting line kind of going down the center. And actually, let me see if I can't. If I go back to this one, I can probably get, yeah, let's do that. Okay, never mind. Download this Eagle mold. No, wait, this one still has the same error. Never mind, I thought I had fixed it in that one, but I guess I didn't. We're good. Keep that same one that we have open. I made this so that way it has a draft angle going across the entire part. And I've just got this one little spike right here, which is kind of in violation of that, which we'll more or less ignore as we're going forward. And that's an artifact of the mirror. And when I did the mirror tool, it kind of included that weird geometry where it doesn't quite come out evenly. Honestly, probably I could fix this by going into do a body mirror, but I'd have to delete that and redo it. So we'll look at that later. Anyways, everybody's got this file. Everyone's kind of see that we've got a draft angle kind of going across this out of the front. And so that's what we're going to use to make our molds. We're going to generate a part. We're going to design the part so that there is a natural parting line somewhere inside the geometry of the part as we're making the initial part. And then we're going to generate the mold by subtracting the geometry of our part from a secondary geometry that has essentially the void into it. Sound good? So all I do is guys specify how big do I want my mold to be to go around this part. And usually that's pretty easy. I'm going to go to the top plane, looks like the one that kind of goes through this part. And I'm going to sketch on that top plane. I'm going to use a center point rectangle, and then I'm just going to make sure that rectangle is bigger than the part. If I want to add dimensions to it, I can. And typically what I would want to do is I want to just make sure that the dimensions make this part somewhere bigger than the edges of the part itself. So I'm going to do something like that. Maybe I'll do something like this. And maybe I want to specify how big this actual box is. That way I know how big whatever stock material I'm going to use to make the mold has to be. And if you wanted to have two sets of dimensions on both sides, or if you wanted to leave this underdefined because you didn't care, you don't have to specify those dimensions. But it's usually a good idea to fully dimension anything you're going to do in SolidWorks. So Everyone got a rectangle that covers the area of the part? Anyone not have that? All right, we're going to features. We're going to do extrude boss base. We're going to do a mid-plane extrude. So change the direction from blind to mid-plane. And I want to make sure that this is thicker than my part. So I'm going to change this 0.1 to 0.25. And that's actually thicker than the part. Again, I could go thicker, I could go thinner. It doesn't need to be a lot bigger than the part. So as long as it's big enough than the part, that whatever manufacturing method I'm using to make this is not going to deteriorate because those walls are too thin, then it's thick enough. So if I want to 3D print this, I probably want to make sure that the offsets between my part and my box that I'm building around it are larger than whatever the resolution of my printer is. So in this case, the Z height is going to be like 0.2 millimeters, and then my line thickness is going to be like 0.4 millimeters. So as long as my offsets are more than that, I'm okay, right? If I was milling this, I'd probably want to make sure that I wasn't getting the thicknesses too thin, such that when it's milling it out, it tears the edge or the bottom of that stock material. Other than that, I might be okay. If I'm injection molding this, I want to make sure that the walls are thick enough that they can withstand the pressure of the mold, the molding process. Basically, they don't blow out as I'm inserting, hot pressurized fluid into the mold itself. Everybody okay with that? We do not want to merge results, so uncheck merge result. So far, so good. All right, accept that. And now I have two bodies. I have my original part, which is fully encapsulated by a Boss Extrude 7, which is the kind of the bounding box of my mold. What I'm going to do is I'm just going to subtract the interior geometry from my mold box. So when we go to these two bodies, what I can do is I can control click both of them. And then I can right click and then go to combine and then change the option to subtract. And then I'll do, I'm going to do body 7 as the main body. I'm going to unclick that, click on main body, and then click on that box there. And so I'm subtracting the Boss Extrude 6 from the Boss Extrude 7. And if you want, you can show a preview, and it'll show you what it kind of looks like with that subtraction done. You can also search for the combine options up here. Did I spell combine wrong? Combine. Oh, it's there. It's just grayed out. Combines two more solid bodies. I don't have two bodies anymore, so it doesn't give me the option to do it. If I control Z and then go to combine. Yeah, I'm going to do it again. I'm doing it from the search option. So there's the combine, and I can click the main body. I can't really click on the other body because it's inside there, but I can select it from my options here. Again, make sure you're on the subtract option and click OK. So far, so good? Yeah? Just make sure everyone's with us. Next thing we do is I'm going to split this body using this top plane. We can also get to these options under the surface tools. No, it should be body tools. Molds, here we go. So there's these parting surfaces, parting lines. Here's split. You see split there? So I'm going to split the part that the thing I'm using to cut is the top plane. The body I'm combining is that one. So just be able to cut the part. Now I have two bodies. Can you see that? No, it's just split. So if you're searching for it, just search for split. So just a split right here. Let me see that one. It's also under the mold tools to insert molds split. And I'm just using the top plane as the plane I'm cutting with. I'm going to hit cut part. Now I've got these two resulting bodies. I click on my green OK. I got to select the ones I want to keep. Now I've got two bodies. I checked both of the ones. Yeah, so in the split tool, let's go back and do it. I'm just gonna do it again. So in split, the plane I'm cutting across is the top plane. I cut the part. Now I've got these two bodies. I click the ones I want to keep. And then I click on OK. And now I've got two bodies. And what I can do is I can hide one. And there's one half of the mold. And then I can toggle that. I can hide the other one and show the first one. And now I've got the other half. The nice thing about this is if I save this as STL, I'm just going to put this in my downloads folder. Downloads. It's only going to save the part that I have shown. How do I rotate this? 3D view. Rotate is what? That's not fine. So there's, it's facing the wrong way. But you say I have this STL file, which is this part right here. So if I wanted to 3D print this, all I have to do is show one side with the other side hidden, save STL, flip it, show the other side, hide the other side, save it as STL again, and now I've got two halves of my mold. Right? This is the first step in generating molds for your parts. This will give you a non-functional mold. And by non-functional, I mean I have no way of getting the material into the part as this is, right? So this is like the Play-Doh version of mold design, where you can just take some plastic material, and by plastic, I mean it has a high degree of plasticity, it will deform easily, and then put it between the two molds and squish them together, and then take them apart, and I would get, maybe it's like the sandcastle version of a mold, right? There's no real design going into this, but this is the basis that we would use for making all of our future kind of mold components. And we'll take most of the class on Wednesday talking about how to go from this to something that's actually usable as a mold. Okay. Anyone have any questions on that pipeline? Because that's the first way of doing it. Realize that most of the work in that design was around the development of the part such that it could be easily molded. Right? Like I made the part with all the draft angles so that it could easily be taken apart in a two-part mold with a single plane as the parting line. And the only part of it that's like messed up is this little bit right here. And I might be able to patch that. Let's see. I'm gonna show you guys one more tool that I really like. So delete face. I'm gonna try and delete and patch. It doesn't want to do it. Let's try delete and fill. No, didn't work. Let's try it. Can I do it the other way? Let's try the other face. So this option, it tries to delete the face and then fill in by extending adjacent faces to fill in the area. I crash SolidWorks. And sometimes if you have like, I got this little overhang thing I just want to get rid of, sometimes there's like a magic I fixed it for you button. Another half the times it just doesn't work. Save your parts somewhere where you'll have access to them for class on Wednesday. And then go back on Canvas and download the cube part. So go back to, where are we here? Download plain cube. I'm sharing screen, right? Yeah, I am, okay. I was just worried for a second there. I usually see like the green flashing border thingy, but it's not on. Can I not download cube? Download cube. This one's not pre-molded, is it? I see it on Pedro's screen. It looks like you already finished the mold. Did you just go through and do it already? Or is it already like that when you downloaded it? I don't know why mine's not opening. Oh, because I closed SolidWorks. So I had to wait for SolidWorks to reload. So this one is developed using the kind of the default options inside of SolidWorks. I want to show that part. So this is a cube that I made And what I wanted to do with this one is show you how I can achieve a mold that will have a parting line that is hidden along the edges of the cube using some of the built-in features inside SOLIDWORKS. So we'll walk through this. I was planning on just having you guys do it live with me. But if you want to just kind of scroll through the slider bar here, you can. The first thing that I'm going to do here is I want to make a plane where I can see 3 faces of the cube at the same time. If I can see half of my part at some orientation to the camera, and the other half of the part at some other orientation to the camera with none of the faces being hit, I can make a 2-part mold out of that part. So in the first one we looked at, it was very obvious. I could cut that part down the middle at the top plane and then pull it apart into 2 pieces, right? This one here, if I cut it apart about the top plane, I have 2 faces that are at 90 degrees from that. It's not going to demold easily because there's no draft there. There's no angle to allow the part to release from the mold, right? And let's do the draft analysis so you can see that. So if we do draft analysis, which is here, or you can also go into tools, insert molds, and then no. Is it in faces? I don't know where it is. There is a mold bar you can turn on. I think it shows up in that. If I search in here, I can probably figure out where it is. Draft analysis. Let's see. Let's show me where it is. Show location. It's in view, display, draft analysis. Okay. There it is. I didn't remember SOLIDWORKS notes. I don't really need to go that way. I'm just going to do draft analysis here. Nope. What this is going to do is I'm going to specify, hey, I want you to tell me what the direction of all the faces in my part is relative to some normal. In this case, the normal is relative to the top plane. And you can see that we have a 90-degree draft angle, a 0-degree draft angle, and a negative 90-degree draft angle. What I want to be able to do with my part is to have all of the faces on one side green and all the faces on the other side red. Because that means they're all going to have a draft angle that is going in the direction of pull of the molds. Does that make sense, everybody? Yellow is kind of okay. A little bit of yellow is fine. A lot of yellow is bad because it's not going to come out. It's going to suction itself into that mold. And you're going to have a lot of force to get it out, or you're going to have some kind of vent or ejection pin or something like that. And if there's any kind of like expansion of the material, that could be easy. If the material is going to contract a lot as it solidifies, then that might be okay. But it's not good, right? It's not what we want. So if I do a view from here, I can see that there is a plane that's going to have all these faces here having a correct draft angle, and then all the faces on the opposite side also having a correct angle. So to get that plane, I can see that, hey, look, there's a vertex here, there's a vertex here, and there's a vertex here. I can make a plane from those 3 vertices. Any 3 points can be used to define a plane. So I'm going to go to my features, reference geometry plane, and it's going to make a plane that intersects all 3 of those vertices. Great. And now if I do my draft analysis using that plane, you can see I have all those ones are red, all those ones are green. Red and green, red and green. Perfect. It's Christmas colors. I mean, yeah, let's do this. Orange and then black. Well, there. That's like purple. That's not black. I'm colorblind. I'm sorry. There. Now they're all orange and black. Orange and black, orange and black. Now they're Halloween colored. Doesn't really matter. Point is that all of them have a draft angle that is appropriate for the direction of pull, where it's positive on one side and negative on the other side. You really only need about a 2-degree draft angle. These ones are, I don't know, if I hover over it, should tell me what the draft angle is. 90 degrees. Oh no, I clicked on the wrong face. I don't know why it's not telling me the face of it. Oh, because it's black text, so I can't see it. 35 degrees, 35 degrees, 35. They're all 35 degrees, right? Which is fine. It's plenty big enough. That draft analysis is a display. So when you run it, if you want to turn it off, you untoggle the button. Everybody see that? So I basically turn that draft analysis on and off by clicking the button. I got to put example. So it's going to stay there until you turn it off, more or less. That makes sense, everybody? All right. After running the draft analysis, I can have SolidWorks pick a parting line for me based off of that analysis. So that draft plane, that was the first one on there. The next one we do is the parting line. So I'm going to go into this one. I will use the insert mold parting line. And I'm going to say, hey, what's the direction of pull? It's this plane 2. So I got to click the box first. And I'm going to have it do the draft analysis. It just runs it again. Change my colors back to the default. Kind of sucks, but whatever. It says, hey, I found a parting line for you using these 6 edges. This is what the parting line looks like. Fine, great, whatever you want to call it. Everybody see that? We click OK. Now we've got our parting line. I'm going to run that one more time. I'm going to turn my draft analysis, my original draft analysis off because it's hard to see with the black and the ring. So I'm going to delete that. Yes. I'm going to go into tools, insert molds, parting line, and say, hey, I want you to pull apart in this direction. Run the draft analysis. Hey, I ran the draft analysis. I found these parting edges using the edges of your part. Click OK. And then we're good. Now, I could have done this for my eagle one too, except for it would have hated that little like wonky piece I had right at the top of the eagle head. And it would have worked kind of okay. It's the next step that I tend to not like about using this auto analysis, which is the parting surfaces. And it works good like 5% of the time. It depends on the geometry of the part. I'll show you what I mean in a minute here. So we can do next step, we're going to insert molds, parting surface. We do have to do it in that order because we have to have the parting line before we can do the parting surface, right? So perpendicular to the direction of pull is going to specify the direction of my parting surface. So in this case, my parting surface is going to be kind of parallel with my, my plane 2. I can also do it normal to the surface and then it just lines up with the surfaces themselves. It doesn't really matter. Perpendicular direction of pull is usually better because it's going to give you kind of a more makes sense kind of geometry to use. And then you want this direction coming out to be big. Bigger is better. That surface needs to go all the way through whatever you're going to use as your bounding box for the mold. So there's no reason for it to be small. And this is usually where it kind of comes into issues because if I have like a U shape, it wants to extend those surfaces like into each other, and then it gives you errors because it's got like multiple surface kind of inflex. So it doesn't always do a good job of kind of healing that gap. We got that. Just make this big. Give me like an inch, make it a half an inch, make it something like that. It doesn't need to be that big, but that's doesn't hurt anything. Just pausing for questions. I'll accept that. And then the last thing I want to do is my tool splitting. And the tool splitting is going to be 2 steps. First one is specifying kind of the geometry of the mold itself. And the second step is just kind of running the analysis to cut it up into pieces. So I'm going to go back into my tools, or sorry, my insert. I'm going to go tools, molds. I want to do my tool splitting. Why can't I do my tool? Oh, I got to generate the part first. So inside the tool splitting, I can't show you because it's hidden. There is the sketch that I'm using for the tool splitting. So I'm going to go hide that again. And let's do the sketch for our tool splitting. So I'm going to do on plane 2. I'm going to generate a new sketch. And can I just offset? Let's see if I can just offset each of these edges. Yeah. Just click on that chain, offset. 0.1 inches is fine. Again, that's on my plane there. You can kind of see how it projects out. And then I'm going to use features. Do I need to do? I think I can do tool splitting with just that plane or my sketch. Wait, where'd it go? Oh, I have to accept the sketch. There we go. Now we can do insert molds. No? I may have to extrude that first. So let's do extruded boss face. I'm going to do 2 directions here. So the first direction, I'm just going to increase this out until it goes all the way through my part. Second direction, same thing. And then I'm going to turn the merge results off. And so kind of the same process as I had last time, except for I don't keep that other piece. And then tool splitting. Tools. There, insert molds. Why won't you let me do tool splitting? So this is the mold tools bar. It's got all the different kind of analyses that I want. Split line draft, move faces, scales, shut off. Inserts the tool split feature to create a core cavity parting surface and interlock to help align mold blocks. Core. Whenever you don't know how to do something, help menu. Tool splitting. I'm just missing a step. To create the core and cavity blocks for a mold, to create tool splitting, you need to have at least 3 bodies in the surface bodies folder. A core surface body, a cavity surface body, and a parting line surface body. Yeah. I mean, I could just split it using the split tools, but I shouldn't have to. Let's see here. Hawkridge has usually good videos. So they've got the part. Are they just doing this the manual way? They're doing it the manual way. That's not helpful. I got the parting surface and the body. Insert. Do I have to select all 3 of these? Here, you know what? Let me save this as a separate file. If you go online to last year, I don't remember having this issue. I remembered how to do it last year. Where is my cube part? File, open recent, plain cube. This one, I can edit my feature. I can try and edit my feature. My core parting line 1, my cavity parting line 1, and then my parting surface. So I need my parting line and my parting surface as inputs to this, which I had both of those inside the part. So why? Yeah, you got it figured out?
I think it's because they already exist here as surface bodies.
Parting surface. Oh. In this suppressed version, they don't, though. I have the parting surface 2. And then I have my parting line. So it looks like in here, I just had these 2 bodies selected. Yeah, it could be because I already have them that exist inside the part. I don't I don't think that's it, but let me try deleting them. Yeah, darn it. It's because they already existed inside the part. That's annoying. All right. So without, if I don't actually already have a tool splitting inside the part, even though it was suppressed, I guess you can't have them twice. With the parting line and the parting surface, then I can come into my insert molds, tool splitting, and then I have to click where I want to make my sketch, or I can use an existing sketch. I suppressed my box extrude, so I'm just going to do this again. There's my plane features. Sorry, my sketch features offset. No, not that one. Nope. Not you. Delete. Offset entities. This guy, this guy, this guy, this guy, that guy, and that guy. That's the same sketch I made before. Exit the sketch. And then there's the distances here. So I'm just gonna make it 1 and 1. And then my core, I should use my, oh, I have it hidden show. Oh boy. Let me click my parting surfaces on here. That's my surface. Why won't you let me select these? I'm going to try and just do this all over again. I don't know. I think it's because I have too many things inside here. So let's just do all that. I'm going to show my body. You guys just watch this for now. So again, I have my body. I have the plane I want to part across. I'm going to do an insert. I'll use the tools over here on the left. Let's do, we need our parting line first. So here's our parting line tool. We use a direction of pull, run the draft analysis. It gets the edges for us. We go to the next step inside the list. We don't have any shutoff surfaces because there's no cores. So parting surface, just make that bigger. Accept that. Tool splitting. Select our planar face for drawing the sketch. Our right plane. We're going to offset the edges around that. Good for me. Accept the sketch. It automatically fills in all the stuff it's supposed to have exactly like it's supposed to work with no errors at all. Extend the part or the extrusions out past the edge of the part. Accept that. Voila, I've got my 3 bodies. I can hide my surfaces. So my parting surface, I'm just going to hide that. My tool splitting 1, hide that. My actual insert, my part, I'm going to hide that. And I got all these surface bodies I need to hide. Can I just hide all of them? There you go. And so there's 1/2 the mold. Show, hide, other half the mold. I guess the long and the short of that is don't try and do it twice on the same part. If you go through parting line, parting surface, tool splitting, it works. If you mess with stuff and try and do it a second time, it doesn't work. I was expecting this part to start with a cube. I think last year I just made the cube during class, and then we went through and made the part, just the whole thing from scratch. Don't worry about that. As long as you guys kind of understand the workflow for how to use the parting line and parting surfaces inside SOLIDWORKS, then it's fine. You can just submit the part file that you downloaded off of mine. I do want to make sure that we are clear on probably the most useful tool in the actual mold tools, and that's the draft analysis. I'm going to change this back to defaults because modifying one, it's not good. I don't have my plane, right? This is extremely useful in figuring out whether or not your part is appropriately designed to be able to make a mold out of it. And like more so than the design of the mold itself, if your part is not moldable, you're going to have a hard time. Okay. Anyone have any questions, concerns on that? Pretty straightforward. So what have we looked at today? We've looked at adding and subtracting bodies. We've looked at splitting a body using a plane. And then we've also looked at using the tool splitting option to split using the surfaces made through the mold tool options, right? And some of the issues associated with doing those kinds of things. On Wednesday, we're going to take the part that we use to make the mold for our eagle design. Let me close these guys. And we're going to modify that part to make a treed mold where you are actually able to make 3 of these eagle kind of talisman pieces using a single injection point. And we'll also look at adding things like vents and channels to help that thing mold more easily. And we'll talk about some of the things like how you might want to specify the direction of the mold and those kinds of issues. So that's kind of the plan for class time on Wednesday. Do anyone have any questions? No? All right, just a quick announcement. We are going to be doing our CSWA, CSWP